Okay, let's go ahead and let's get started with the ADI lab for the week. I'm going to go over the different aspects of the lab, the different categories where you need to list things, and I hope that this video serves as a guide. I do want to remind you that this is a large portion of your grade. It is worth double in the grade book, so doing well on this will help to ensure that you have a high grade by the end of the quarter. So this is a list of each aspect of the lab and how I'm going to grade it. The most important thing is that while you're working, you are maintaining the focus on what the objective question is for your lab. I want to see that you have evidence of the scientific method, that you are following experimentation, that you're listing data. Data is going to be a huge portion of this. In the lab, we have placed areas for you to write down answers to a variety of questions. And as I grade this, I do want to see that you have answered all the questions fully. That does mean that you need to have complete sentences as your responses to the questions that are listed within the lab. Effort, neatness, legibility, that word simply means that I can read it. It is readable. So your letters look like letters, and I can decipher what you have there. So do make sure that you're making an effort to be as legible as you can with what you're writing. I want to see that you do have the data from your experiences in the lab and that you're actually using that as you are drawing those conclusions and you're answering some of the database questions in the lab. So let's go ahead and let's begin. In this investigation, you will explore the relationship between potential energy and kinetic energy as you try to make an action figure jump using a teeter board. So one of the things in the lab that you're going to be asked is, what is your guiding question? And we have placed that right here for you. If you're ever confused about what to do or where to go next, just go back to your guiding question. That is the purpose behind the lab. Your task, use what you know about energy and models to design and carry out an investigation that will allow you to develop a rule that explains how an action figure can be made to jump lower or higher on a teeter board. So let's just take a second to look at what the variables are going to be. In every scientific experiment, you have an independent variable and you have a dependent variable. So in this experiment, you have two basic independent variables that you're allowed to kind of manipulate and play around with. One of them is going to be how much clay you use. And as you can see here, you have up to 100 grams to work with. A second independent variable is going to be the height at which you drop the clay. Now, depending upon which of these variables you want to focus on or whether you want to focus on both, the dependent variable is going to be how high the figure flies up or the figure propels itself into the air. All right. So the height of the jump is going to be the dependent variable. But again, one basic concept of science is that the independent variable will always influence what the dependent variable is. So right now, as you begin to talk in your groups, we're going to pause the video and give you about a minute or two to discuss the answers to A and B, and then go ahead and take some time to answer those questions and complete sentences. So we're going to go ahead and pause the video now. give you guys a chance to answer those questions. But first, you need to talk. So you're going to talk, then you're going to write. So go ahead and let's do that right now. Just put your pencils down when you're ready to move forward, and I will know. That'll be my signal to continue. Another answer that you're going to have to address here is going to be what measurements we are going to have to record. So what are the measurements, what are types of measurements, and what are the observations? Now I do want to say something here. Before you begin to answer these, remember that as you look at these words, measurements and observations are plural, not singular. So go ahead at this moment, talk in your groups, and answer question C. The next question is going to ask about data. How will you collect it? So, question A, how often will you collect your data? And what, sorry, this is a mistranslation. What will you do with it? So, how often are you going to collect data? And what are you going to do with the data? And the second question here is, how will you make sure that your data are of high quality? How will you reduce error? So take a moment with your group and answer those questions. The next question is, how will you keep track of the data you collect, and how will you organize it? Take a moment to talk about it in your groups, and go ahead and answer this question using complete sentences. The next question is asking you to think about data analysis. How will you analyze your data? We want you to think about these questions. So analyzing data, when we say that, what we mean by that, what that means for you. Let me go ahead and make sure my marker is working here. All right. So to analyze, that's another word that means to understand. So when we say analyze your data, what we mean by that is to look at it and understand what it's trying to say. What do the numbers teach you? What do the numbers show you? So the two guiding questions here are A, what type of calculations will you need to make? And B, what type of graph could you create to help make sense of your data? So remember, the graphs can help us to understand data, make sense of it. Think about what type of both of these you're going to need to have. Again, this is something that you are coming up with. It is not something that I'm directing you to do or telling you to do. These are your ideas. Go ahead and answer that in your groups after you take a minute or two to talk about it. So today, the last thing that you need to do is you need to write down your procedures at the bottom. Now, the important thing is that you have at least 10 of these, and that they go from the first thing you do to the last thing you do. You might need more than 10 steps to fully express that. List procedures here. Procedures should be as detailed as possible so that someone else can recreate your lab exactly the same way you did. Write the procedures you would like to do before the lab and edit as needed while you complete the investigation. So before you do the experiment, before you do the lab, you need to list your plan of action. That's what this is. So your procedures are your intended plan for how you're going to carry this out. So I just want to remind you of how we're going to essentially be implementing this. You are going to have some kind of a round cylinder, maybe a marker, maybe a canister of some kind. And on top of that, we're going to give you a ruler. You'll have a little action figure, and you'll have some clay. Now, you could have any amount, anywhere from, say, 10 grams to up to 100 grams. And you're going to drop that, and you're trying to make the little guy fly up. Now, you could drop it from a higher height. If you do, is he going to fly higher or lower? You could use more clay. If you do, will he fly higher or lower? We don't know. That is what you are going to discover. So taking that into consideration, take some time, talk with your group members, and go ahead and finish writing down your procedure. This is the last thing you will need to get through today, so it is expected that you take some time with this and that it is of high quality. Today you're going to go ahead and move through your experiment. So you're going to follow your procedures. And while doing so, you're going to collect data. You want to make sure that after you collect the data, that you do have those indicated in some kind of a graph. I suggest making a table first. So your data table is just going to be like this grid formation where you're going to kind of list numbers and list words that kind of are associated with those numbers. And then later you're going to take that data and you're going to create a graph. Now, I'm not going to tell you what kind of graph that you need to make. That is up to you. But remember that different graphs are appropriate for different types of information. This is something that you need to decide on. This is something that you need to talk about in your groups. As always, we are here to help you, but with these ADI labs, we really want you to be the person making the decision. A great way to kind of summarize that and put that in simple terms is that we expect you to be the scientist. Now that you have completed the lab, you are going to present an argument. You're going to take the argument that you have and you're going to design a poster to illustrate that. Afterwards, working in groups, you're going to go around the room and see what each other group has done and what they have discovered from their science exploration. So you are going to share with one another, and then you're going to critique one another based upon what each person has done. Again, this lab is all about you discovering things, figuring things out, understanding how the natural world works. Initial argument. Once your group has finished collecting and analyzing your data, your group will need to develop an initial argument. Your initial argument needs to include a claim, evidence to support your claim, and a justification of the evidence. The claim is your group's answer to the guiding question. Again, let's reiterate that. The claim is your group's answer to the guiding question. That means you probably should go back to the guiding question to make sure that you adequately and directly address that. This guiding question is the most important piece of this lab. And remember, it's an essential component of the scientific method. Question is the beginning of the scientific method. So please go back to that guiding question in your lab to make sure that you are addressing that. The evidence is an analysis and interpretation of your data. Finally, the justification of the evidence is why your group thinks the evidence matters. So please read these instructions. We're asking you to provide evidence. We're asking you to provide a claim. We're asking you to interpret. Look at all these verbs, okay? And then the justification of the evidence is why your group thinks the evidence matters. The justification of the evidence is important because scientists use different kinds of evidence to support their claims. Your initial argument should include all of the following information. And as you look at this paper, you're going to see different boxes where you can write this information. Again, remember that as we grade this assignment, we are looking for complete ideas, which means complete sentences. If you do not write incomplete sentences, it's going to be difficult for us to really understand what your point is and what you're trying to express. The last thing we'll do is move around to different groups to find what their argument is. They will present their arguments. The argumentation session allows all the groups to share their arguments. One member of each group will stay at the lab station to share that group's argument, while the other members of the group go to other lab stations to listen and critique the arguments developed by their classmates. So again, you're going to have one person that kind of stays at your table that's going to explain what you guys did. And all the other kids in your group are going to move around to other stations to listen to the people at those stations explain what they did. And so you're going to kind of share ideas. You get to decide who's going to stay behind and who's going to go. But this is similar to how scientists present their arguments to other scientists at conferences. If you are responsible for critiquing your classmate's argument, your goal is to look for mistakes so these mistakes can be fixed and so they can make their argument better. The argumentation session is also a good time to think about ways you can make your initial argument better. Scientists must share and critique their arguments like this to develop new ideas. To critique an argument, you might need more information than what is included on the poster board. You will therefore need to ask the presenter lots of questions. Here are some good questions to ask. And if you look at the paper, it lists many questions that you can ask. But the idea here is that we want you guys to be scientists as you go through this exercise. This is going to conclude your lab. And I do want to remind you that it is a major portion of your grade for the entire quarter. I have made this video to help you have the highest grade possible. And nothing makes me happier than making sure that my students have as many A's as they can have. So please use the information that I have presented to get the highest grade possible.